Right, I have to upload it to the similar YouTube channel. Even though I have to speak in English here. Right, this is the database hacking lesson. So far, we have discussed up to the relational model there. Relational model. I have already uploaded one video related to the relational model. Relational model. Relational model. Actually, the relational model means the tables. Relational model means the simply words means it is the table. Creation of the tables. Right now, today we are going to discuss about the mathematical aspects of the relational model. Okay. Now, when we are going to design the database system and when we are interact with the ethical hacking scenario of the database, we want to know how uh, how does the database is designed mathematically. Okay. So that's today we are going to discuss that aspects. Okay. Right. So I will come slides. I think you can see these slides. Can you see the slides here? I will
Yes,
upload
sir.
this to the group. Okay, this is the relational model. Okay, now the relational model is designed using the theory of relations. Relations means one of the parts in mathematics that is actually uh, related to the field of sets. There is a special part in mathematics called set theory. Okay, to that area, these relations are combined. Okay, right. So relational model represents how data is stored in relational databases. Using this model, we are explaining how is the way of arranging the data in the relational databases. A relational database stores the data in the form of relations, and we have already got to know that in a relational database, the data is stored as the form of tables. Okay, relations means the tables, right? Okay, we'll see the mathematical structure of this one in the relations. What is the mathematical structure? Relation is the relationship between different types of entities. So what do you mean by the relation? Relation means a relationship between different types of entities. Okay, now we are going to see what is that mathematical, uh, how does the mathematics combine to this one? Relation is defined as a n array tuple. Okay, relation is defined as a n array tuple. Its n attributes a1, a2 up to an. Each attribute ai comes from a domain di. Okay, again, relation is defined as a n array tuple. Its n attributes a1, a2, a. Suppose there are n attributes. Okay, then this tuple can be represented like this way. Okay, I will take this. Tuple means you are taking this parenthesis and you are representing the value inside that one. Suppose the attributes are like this way, a1, a2, like this way. If you are representing like this way, it is called a tuple. Okay, it is called a tuple. So relation is defined as a n array tuple. Okay, its n attributes a1, a2 up to a. Each attributes ai. Okay, that means anything here. Okay, any attributes ai comes from a domain di. That means this what we call domain means the range that is belongs to. That means if you consider about the attribute, okay, any attribute, suppose it is a database like this way and a table like this way, it has certain columns. Okay, This column represents the attributes. Okay. If it is a student table, if it is a student table, okay, what are the attributes that you can put here? Just give me some attributes here of a university database, and you are going to store the details of a student. What are the things? What will be the primary key?
Student
Primary
ID.
Student ID. What else? Name. Okay, interact, guys. Tell me the things.
NIC.
Yes, address, name, address, what else? Phone number, email, like that way. You can. Okay, these are the attributes. Okay, right. Then now these attributes, those are belongs to a certain domain. That means now if it is a if it's ID, okay, perhaps it can be the first letter can be letters from A to Z. Okay, if it is now suppose the ID is student's ID is comes with the two letters, like if it is the name like CS. Okay, if the student is doing cyber security, CS 15158 or like this way. Now these two letters belong, the first two letters belongs to the letters from A to Z. A to Z. Okay, that means these two numbers belongs to the what we call the characters, character domain up to A to Z. These two, and the other rest of the digits, those should be numbers. Okay, 0 to 9, 0 to 9. Here these numbers should be like that. That is one of the that is their domain. If it is a name, all the name should be what? Those are characters. Name should be in character type. Okay, and address, you can say it is a text type, like that way. You want to explain what is the domain, what is the range which is, that it is belongs to. If it is a roll number, it should be integer, like that way. You can explain what is called the domain. It means a particular relation is formed of n attributes ai to an. Each attribute ai comes from a domain di. That is, ai belongs to di. ai belongs to a di. That means with a, b, c, like that way, what I have mentioned, these are the attributes. Okay, these are the attributes. These are the attributes. Each of these attributes belong to a certain domain. That is the representation of this one. All of those attributes belongs to a domain. Okay, domain means any domain. Okay, right. So a relation R is a subset of the cross product of the sets of di. Right. Suppose now ai, okay, ai belongs to di. Okay, a1 then belongs to d1. Okay, a2 belongs to what? d2. Like that way it is going, like that way. Suppose if it is going like that way, ai belongs to, like this, ai belongs to di. That means the ith attribute is belongs to di. Then if it is a1, it is belongs to d1. a2, it is belongs to d2. Like that way it is going. So how do we define the relation? Remember, relation is a subset of the cross product. Subset of the cross product of the sets of di. What is the sets of di? This is the di set, the domain. Domain set means d1, d2, d3, d4, like that way it is going. Cross product of the di means you are getting the multiplication, but the vector multiplication, cross, this is cross. and this is dot d. If it is d1, d2, okay, this multiplication methods are different. Now, I don't want to mention about the dot product here. Okay, we'll consider about what is called this cross product. Okay, cross product. Okay, okay, right. Cross product means you are multiplying those things, but we'll see how do we multiply the things. Okay, we'll come to the next slide, and you can get an example from there. Okay, here, see, what are the things available? Suppose we have two sets, D1 and D2. You are having two sets. What are the name of those two sets? What are those two sets? D1 and D2. These are domains. Okay, domains. D1 equals 2 and 4. D1 equals, the set is 2 and 4. D1 set is 2 and 4. These two are available there. D2 set is 1, 3, 5. Okay, what is this Cartesian product or the cross product of those two sets? Okay, how do we take the cross product? It is represented like D1 cross D2 is the set of all ordered pairs, such as the first element is a member of set D1 and second element is a member of set D2. How do we get this one? See, how do we get this one? D1 cross D2, D1 cross D2, we can get it like this way. Okay. Put a braces, and you are getting the ordered pairs of these things. Okay, the first one into the first one and this one. Okay, now the first one is what? 2. Okay, 2 and 1. 2 and 1. This is the meaning of the cross product. Okay, the first one is from the first and the second is from the second. Okay, you want to get it in a regular way. 2 and 1. Then the first one and the second one. 2 and 3. 2 and 1. What has I done here? 2 and 1. Comma. Then what is that? 2 and 3. 2 and 3. Okay, what is the next thing? 2 and 5. 2 and 5. 2 and 5. Then another two things are with 2, all those things are finished. Now after that, take 4. 4 and 1. Comma 4 and 1. Then what's that? 4 and 3. And then 4 and 5. What is the 4 and 3? It is missed here. Okay? 4 and 3. This is the way of getting those cross products. So Cartesian product means like that. Okay. Now this is the total Cartesian product of this what we call two sets. That means domain. Domain means this the product of these two. Okay. Now what is called the relation? Relation is a subset of this thing. Okay. Now there are how many ordered pairs? 1, 2, 3, 4, 5, 6. Okay. How many ordered pairs are available here? 1, 2, 3, 4, 5, 6. If you get a subset of this domain, okay, we can consider it as a relationship. Okay. Subset means you can take the full thing also, or you can get some sort of subset from that one. Now, if I get 2, 1 and 2, 3, you can consider it as a relation because it is a subset of this whole thing. If you get just 2 and 1, that is also another relation. 2 and 2, 5, that is also relation. 2, 3, 4, 1, it is also what? Relation. 2, 1, 4, 1, it is also relation over D1 cross D2. Did you understand that one? How do we define a domain as a Cartesian product, and how do we get a relation from that domain? Did you understand that one? The mathematical relation? Did you understand? Guys, did you understand? Respond. Everybody
Yes,
respond.
sir.
Right. Then we'll move to the next slide. Okay, then the relational model mathematical definition. What is the mathematical definition? Mathematics define relation to be a subset of a Cartesian product of a list of domain. Now we have taken the list of domain. That D1 cross D2 is the list of domain. If you get a subset of that one, we can consider it as a relation. Okay. Now, if these are the sets of domain D1 cross D2 like that way, if it is going, the relation of that set you can consider as n tuples where AI belongs to Di. That means if you get a attribute from one of the domain, okay, you can consider it as a relation. Right. See this one. Mathematics define a relations to be a subset of the Cartesian product of a list of domain. Okay, right. Like this example, I am told that this is A1, A2, like that. If it is going, we'll say consider about the real world example. A1, it is a customer name. Okay, it is a customer name. The customer names are like the John Smith, Curry, Lindley, like that way. It is going. And A2, it is a customer street. These are the attributes. Okay, customer street and the customer city. If it is like if it is going, you can take the Cartesian product of these things. Like what is that? Jones, Main, Harrison. That is one of the Cartesian product. Okay. And how's that? Second thing, Jones, North, right? Like that way you can get another one. And Jones, Park, Pittsburgh. Like that way Smith, North, right? Like that way you can take number of the combinations inside those domains. Okay, while considering those combinations, if you take some sort of subsets, you can consider it as a relation. Okay. Name some relations from this area according to this example. Name some relations, guys. Name some relations. Represent some relations in the form of those representations by using those notations. Now I ask, you can consider the domain from these three attributes. You can consider about the domain. Domain means you are considering the all of those things. Okay. My question is not to find out the domain, find out the relationship from these things. And write in the correct format quickly. At least the three things, right? Three subsets. And you have to write it as in the correct format because we are discussing the maths here. Okay, this is the mathematical part of the design. So you have to give me in the correct format. Yes, R equals curly brackets John main right. Yes, Smith. Can you write like that way? See about the Krishnanth example. Can you get that Smith along? Can you get that Smith along? Because if you get this Smith along, there is no product of that one. You want to take the products. If you take one of, you have to take one of this one here, and you are multiplying by this one and this one. So John, Main, Harrison is one. John, North, right? That is also another thing. John, North, Harrison is also possible. Okay, like that way you want to go. Okay, all those three should be included. Smith, North, right? Curry, Park, Pittsfield. Linde Park, Pittsfield. Like that, you want to take all of those. Okay. See the example relationship. R equals what? Curly brackets. Put the curly brackets. Jones. Yes, Jones. Then what's it? Take one from here. Main. Harrison. And that is one tuple. Okay. That is one tuple. You want to take tuple. Tuple wise you want to take. Okay. This is one. Then what's that? Put a comma. Another one take Smith North Drive. Smith North Drive. And Curry Park, Pittsfield. Here they have taken Curry North Drive. Yeah, anything. Okay, Curry Park, Pittsfield, and Lindsay Park, Pittsfield. Okay, like that. You want to take, but you can't take this one on alone or two things alone. Okay, otherwise you have to take the Cartesian products. Okay? Without taking the Cartesian product, you can't take the relations because you have to take what's that subsets. Did you understand? Right. Right. See, this is the first tuple. Tuple wisely you want to go. Okay. In a tuple means what? You are taking complete row. Complete row. If you are taking a complete row, can you have missing parts there? You are taking a complete row. Complete row means you want to take all those things. Okay. The first tuple and Smith North right. Second tuple. This is the third tuple. Like that way you can take. Okay. And the next thing you want to understand, these relations are unordered. These relations are what? Unordered. There is no order for these relations. Okay. There is no order. Okay, you can now like this consider this customer name, customer street, and customer city. You can interchange these things. Okay. There is no convention like this customer name should come as the first column, the first attribute. Not like that. There is no something like that. You can interchange, and also you can interchange these tuples. Okay, this is the first tuple, but you can take this thing as the first tuple. Okay, anything you can change. Okay, in relation model, relation is defined as table. The relations are mentioned as table in relation or table. Order of tuple is irrelevant. Tuples may be stored in arbitrary order. That means it is a random order. Okay. Therefore, relations you can consider as they are unordered. Okay, this relation say John's main Harrison. John main Harrison. That is the first one. Smith North Drive. Smith North Drive. Curry North Drive. Curry North Drive. Lindsay Park. It's like this way it is there. But this tuple can come as the second tuple. Like this way you can interchange. Okay. Next thing is the attribute types. Okay, there are several types of the attributes. One thing is the named attributes. Okay, that means this has a name. Each attribute of a relation has a name. Okay, that means you know that each of those attributes it has a particular name. Okay, it should be unique. Then the domain. It should have a domain. This domain means what? The set of allowed values for each attribute is called the domain of the attribute. That means what is the possible values for that attribute? We call them as the domain. If you consider about the roll number should be a numerical value. Suppose it is 10 digits value. 0 to 9 values can take for the roll number. If you consider about the name should be a character. This is the range of that one. 1 to 30 digits should be there. Okay, characters should be there. If you consider about the date of birth as the attribute, the data type should be date. and this is the way, date and the month and the year. Like this order, it should come. This is called the domain of those things. And attributes should be atomic. Atomic means it should be, you can't, atoms are indivisible. Okay, atomic means you can't subdivide these attributes. Okay, as an example, you if your attribute is the name, you can't composite it like middle name, like that way. Inside that attribute, you can't subdivide the things. Okay, in that particular uh, attribute column. Okay, if it is the name attribute, you can't have something like middle name like that way. It should be the name, and also it cannot be multi-valued. We have discussed about what are called multi-valued attributes and what are called composite attributes. Guys, give me an example of multi-valued attribute. Guys, you give me an example of multi-valued attribute.
Email.
Yes. Yeah. Emails, phone numbers. Good. Okay. Give me some examples for composite attributes. Composite. Composite means
NIC.
NIC. How do you say it is composite? Yeah, street has now, if it is a combination of several parts, okay, you can consider it as a composite. If you take the name can be name will be a combination of first name, middle name, and the last name. Okay, those are composite attributes. And also the street number, area, like that. Certain things are available. Those are considered as composite attributes. Okay, right. Now you cannot have attributes as if the attributes having multi-values, you cannot put it as an attribute in the relational model. Okay, and also you cannot have composite attributes because those are not atomic. Attributes should be atomic. And the next thing, null. These things you will get this thing when you are designing the databases. I think some of the students, you have created some databases, and there was a practical, and you have built up a database, isn't it, by using my Microsoft SQL Server. Have you done that practical? Did you create that database? Okay. Are you there, guys? Can you remember that practical? That guy has done it nicely. Did you remember the way you have created the database there? At least, can you remember
Yes, sir.
you were in a practical? Okay. Install but no went deep. What do you mean? That means install means haven't you created the database there? Didn't you create the database using my SQL Server or MySQL? Like that way, you didn't create the database. You just install MySQL, but you tend to deep. I think that you have completed that task. Okay, then you have to arrange a separate workshop for the creation of that. You should get it deeply. Otherwise, it is not the cybersecurity. Cybersecurity means you have to get those things because the time might not be enough for this because it will take some long time. Isn't that so? it has taken some time. Yes, we have to design it step by step, and somehow I think that you have got some hands-on experience in the first experience. Okay, you have to do that one because I will also explain that one. Right, they are. Haven't you get this experience as a null thing, or did you see this thing null? Yeah, no, can't remember. What is this null? How this null values are coming? Null is coming. Null is coming because of this. Okay. If the entity does not have anything to store, one thing. Entity does not have anything to store. Entity does not have anything to store. That is one thing. Okay. If you are having the entity and you do not have anything to store, then that is a null value. Okay. The next practical, try to identify this. And if it is not applicable, not applicable, not applicable, not applicable. What do you mean by the not applicable? Right. We'll get some names. Okay. Amal Pereira. Okay. Then we'll take Sandini Basnaik. Sandini Damayanti Basnaik. Take another name. Krishantan D. D means the middle name. Okay. Still Raj. Okay. Now, if you consider these three names, okay, this one does not have a middle name, and these two names, they have middle names. Okay, they have middle names. Now, since this one doesn't have a middle name, okay, that what we call, okay, it is not applicable. Okay, it is not existing. Okay, it is not existing. So you can give it as a null value. Okay. If you take like the columns, the first name, okay, now not in one attribute, okay, if you are taking several columns, okay, like that way you are taking the thing. If one thing is missing, one value is missing, okay, you can put it as what? Null. You can put it as null. And also this, if something is unknown, if something is unknown means you don't know the value of this. If you do not know the value of this one, or if you the value is existing but that value is missing. One thing is you do not know the suppose now your grandfather's name. If you do not know the grandfather's name, okay, if you can't store the grandfather's name, then it is null. And in some birth certificates, they have asked a question. Okay, now those days the birth certificates were not stored in the databases. Now just the file management system. Okay, There is a one question asking your birth certificates. I don't know whether it is available in your birth certificate. Mutta upanne Sri Lanka Vietnam. Muttage 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 Tattage Nam. So we do not know the name of the Mutta's Tata's name. So that one we have to put as a null value. So in single we are putting it as Nodani. That Nodani is the null value. Okay? That Nodani is the null value. If you the value, there is a value, but if we do not know that value, that is a null value. And also the second thing, okay, we are not aware of that one, then also we can put it as a null value. Okay, that is the null value section. Right. This null value, you have to be very careful with these null values, because these null values can make big complications. Null pointer exceptions can come, okay, in some cases, because of these things, the null values. Okay, right. Then the relation schema. The relation schema. The schema means that is the description of the relation. Okay, now if you consider about the relation, the description of that relation is considered as a schema. Right now, A1, A2, and AN are the attributes. If you consider A1 to AN are the attributes, this relation R. Okay, this R, capital R is the relation schema. Relation schema can be represented as a tuple like this way. These are the attributes which belongs to that relation schema. A1, comma A2, comma like that way it is going. These are the descriptions. These are the descriptions. Okay, all of these description is considered as the relation scheme. As an example, yes, excuse me for a while. Right, that's so. I think right. Okay. Right. What do you mean by schema? Guys, what do you mean by the schema? That is the description of the relation. Guys, did you get that point? If it is the customer schema, all those attributes should be involved in that relation schema. That means customer name. Okay, customer schema means inside these parentheses, you are putting the customer name, customer street, customer city, like that. If it is a student schema, what do you want to put? Student name, student address, student phone number, like that way, the available attributes you are putting. A relation is defined over a relation schema. That means now this relation is the simple R. Okay, this is the notation. Relation is the simple R, and relation schema is the capital R. So we are representing it as simple R inside bracket capital R. Relation over relation schema. R capital R is a relation. R from the relation schema. As an example, customer is the relation. Inside bracket, you are putting the customer schema. This is the relation, and this is the relation schema. Then the next thing is the relation instance. Instance means the current value which are available in the table. The current values. The relation instance means the current value of a relation are specified by a table. Okay, if it is R, R is the relation. Okay, now this relation means this John, Main, Harrison, Smith, North, Drive, Curry, North, Drive, like that. So these tuples are available. Okay, these current values. Okay, these current values, this first tuple, like this way, we call those things as the relation instance. Relation instance. And element, okay, any element T of R is a tuple. Now this is a tuple. Okay, this is a tuple represented by a row in a table. This is a tuple. Okay, then now this is the relation. Okay, this is the total relation. Now these are the current values available. Okay, the current values means the tuples. Okay, tuples. Okay, tuples means the rows. If you consider about the table, the rows are considered as the tuples. Okay, attribute AI represents column in a table. Okay, now if we consider like the database like this way. Okay, now some values come to this one. You have name, phone number, email. These things are considered as these are the columns. Okay, column represents the attributes. Okay, these are the attributes. These attributes. Okay, and these things we call as the what's the tuple. This elements belongs to this thing. We can consider as the tuple. Database is what? The relation database is a multiple interrelated relations. Now this is one relation. Okay, like this way, this type of mathematical way, you can take another relation. Okay, I told you you can take multiple number of relations by using the Cartesian product. Anything which is a subset of that Cartesian product, you can consider as a relation. Okay, now this is one of those relations, but you can take many r1 r2 like that way you can take, because you know that if you take that Cartesian product of the domain, you will be getting multiple values. Okay, any subset you can consider as a relation, right? Then by using this example you can understand. Okay, this time students, normally we do not write as students. Okay, it is like the singular way you are writing, you go with that naming convention. Better to put in the singular way. Okay, always make it as singular. Student, not students. Okay, roll number, name, phone number, like this way. The things are available. Now you can consider this is a tuple, one of those tuples. Tuple. These are the attributes. This is the conclusion. Okay, the conclusion of all of those things, all of the maths available here. Right here, these are the attributes. Attributes: roll number, name, phone number. The name is student. That is what? That is the relation. Okay, this table. This is what? The relation. Student. That is the relation. Another name for the relation, it is the table. The table name is the student, or you can say it as the relation. Okay, right. Then these are is the 1, 2, 3, 4. Those are the tuples. Tuples means the rows. Rows. These are the rows. Okay. If you take any entity, one of those entity, you can say it as a tuple variable. Okay, this Aman, Vijay, okay, anything, anything, okay, this number. Anything if you have taken separately, it is a tuple variable. Okay. Now, degree means how many number of columns? 1, 2, 3. If you consider about the total number of columns, we consider it as the degree of the table or degree of the relation. Degree of the relation is the total number of columns. Total number of columns. Then cardinality. Cardinality is the what is the total number of rows. Now here, total number of rows are 4. So you can say the cardinality is 4. How do you differentiate cardinality and the degree, guys? Cardinality means the total number of rows. Number of rows. Degree means number of columns. And what do you call the domain? Domain means what is the set of possible values. Set of possible values. If you take the roll number, what is the domain of the roll number? You can take any integer up to 0 to 9. Okay. If you take the name, what is the domain? The characters. And you can give a value. How many digits can be available? Like 30 characters, like that you can get. Or 10 characters, like that you can get. But It is the set of characters. And here, what is that you can give? It is integer, and you can give the indices as how many numbers available. Like in Sri Lanka, it is 10 digits. Okay, then how do we represent the relation schema? Relation schema, it is represented like what? Relation schema means what? The description. First give the name of the relation, okay, student, and inside bracket put all those attributes. How do you give the relation schema, guys? This is not students, it is student. Give the name of the relation, and inside bracket give what? Inside bracket give what, guys? Attributes available. How do you put the relation schema, guys? First the name of the relation, okay, or the name of the table, and give what? Attributes. Okay. Total rows is 5, but cardinal is 4. Right. You can't take this one. Okay. This is the attribute. Okay. This is not counted as a row. This is not counted as 4. This is not counted as 4. What's that? Row. Because the entities are not available there. These are the attributes. Okay. 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 This is attribute row. You can't take. Except the attribute row, rest of the things we can consider as the what we call when we are considering the cardinal. Okay, right. Okay, that's the end of the lesson. Okay, thank you very much, and we will be having the what's that? Today I have put the deep learning lesson at about 10:30 instead of the, and I have interchanged the machine learning and data mining to the next day. And today you will be having the deep learning. Those who have, I think you have already participated for the deep learning first lesson, which I have conducted. And today you will be getting the practical application of that one. So don't miss that one. Okay. Get prepared at about 10:30. Okay. Thank you very much. And we will, I think, do we have classes for cybersecurity tomorrow? I think you have. No? What's that lesson? Is that operating system? Is that OS? Is that OS? Yes. Of course. Is it OS? Or network? Anything. According to timetable, C. Okay. Right. You will be having. Right. And guys, you can participate for the what we call data science by using the same link at about 10:30. Right? Okay. And also the cybersecurity students, I think you can participate for the what we call in the data science. There is a separate module which is called cloud computing. That thing will be suitable for you because for it will be related to you when you go like deep to this thing. That means you are somehow you are getting that one. If you want to get the applications before that, you can come. It will be available Monday at about 10:30. Okay.